Hi, this will be a tutorial on generating synthetic data sets that we can use to validate 3D reconstruction methods. So why would we want to do this anyway? Well, a problem with reconstruction is that we generally only care about the applications for real environments and reconstructing real objects that we can use in 3D scenes. Um, like for example, this is from my website, and these are just some pictures that I happen to have for comparison. This was a reconstruction of a real surgical, like a dummy surgical room that we were using for this research. So, how do we know how good of a reconstruction this is? We don't, because we don't have ground truth geometry for it. We can just look at it and say, oh, that looks pretty good. Um, but as you get closer to the mesh, you may notice that it looks worse and worse. In this case, I think it was actually pretty good, but in this case here, we had a reconstruction of the first floor of Sitterson Hall at UNC, and this wall looks okay from far away. Okay might be a stretch, but when you go closer to the point is that the wall looks flat from this perspective, but from another perspective, like if I move close to the wall itself, um, I might notice that there are bumps in the walls or like things sticking out of it that are not as noticeable after it's textured. Another example might be this is another real scene. It looks pretty good overall, but when you move closer to something like, for example, the side here, where this reflection is, I believe that this actually had a hole in it, or at least it was very bumpy because reconstruction algorithms don't like shiny stuff. Um, but you wouldn't be able to tell from this perspective from which it was reconstructed. But in a 3D scene, like in VR, if you move your head close to it, you'll see, oh, this doesn't look quite right. So by comparing against synthetic scenes, we can judge this more objectively than me just looking at this and saying, oh, this looks okay or not okay. For houses, you have floor plans and stuff that will at least tell you if the walls are in the right position. And for things like furniture, like this bookshelf or this cabinet here, things that don't have stuff on them, like this bed might be troublesome for a furniture database because it has blankets on it. But for a lot of objects, you do have data sets that can help you judge automatically, but it's not going to work in the general case. It's really only going to work for things where you have like the AR models in Amazon. So anyway, the point is that with the synthetic scene, like this is actually from Unreal, we can more objectively tell if the reconstruction, like this is a reconstruction after processing a bunch of images of the scene, we could tell if the reconstruction looks as good as the ground truth. And that's what this is all about. So let's get started. That's just the motivation, but anybody who works in reconstruction will probably know these problems already. I'm going to use this house. It was free on the Unreal Store at some point, and that's when I grabbed it, but there are a lot of other free assets. It has like a nice kitchen and living room and stuff. If you want to find other free stuff, you can just go to the free tab on Unreal Marketplace, and you'll see this is the free asset collection. I would recommend going 100 per page and just adding everything. And as you skim through, you'll find like you'll find different realistic environments like castle, like a mall area. There are plenty of scenes that you can use, but I'll be using this HQ residential house because I happen to have it open already. So it is this, and this is more or less what it looks like at first, except it was, I think that the original scene was nighttime and there were no houses outside. I needed to create houses because we were doing something with audio reflections. Another thing is that it didn't have ray tracing enabled. If you can, you want to enable ray tracing because reflective surfaces and shiny surfaces are really the biggest problem for reconstruction algorithms, and you want to simulate those if you can. Even on a non-RTX GPU, you should be able to get at least one bounce. So the way that you enable ray tracing is well, there's a tutorial on the Unreal website, but I believe in project settings, down to Windows, this needs to be DirectX 12, and this needs to be checked. And then I think in rendering, ray tracing needed to be enabled. There it is, ray tracing, and texture LOD is helpful if you have a scene that has a lot of textures, because I think it automatically computes what the textures will look like far away, or how detailed the rays are from a certain distance or something like that. But anyway, that's how you enable it initially. You'll have to restart your scene after enabling that, I think. And then this scene had a post-process volume around it, and in the post-processing volume, you can enable ray tracing features. So down at rendering features, you can enable like ray tracing, ambient occlusion, which I have disabled because the ambient occlusion already looks okay in the scene. It didn't really change much by enabling it. You can if you want, it doesn't matter all that much. You just have to play with the settings a little. And also it'll cause a hit on your GPU, and as you can see, it's kind of noisy too, so. Ambient occlusion's a post-processing effect that it's just to kind of give everything a sense of depth, so I don't think it's crucial to have that be ray traced. And then you can do ray tracing global illumination, which this does have a nice effect, and as you can see, it made the ambient occlusion a little too strong. But it does, I don't know, I think the original looks better because the light is already baked pretty nicely, and I think the result is a more realistic looking scene. But I don't know, this is up to preference. It could also be that the ambient occlusion is too strong. But I don't know, there's something about the brute force ray traced version that looks like overexposed or something to me, but I'm sure if you play with the parameters, you'll find something that works. By the way, with ray tracing enabled, my recording may lag, so sorry about that. It might stutter sometimes, I noticed that. Okay, more importantly, we have ray trace reflections and translucency. These you'll want to enable, so enable ray trace reflections. I set max roughness to 0.5. This is basically how rough a scene can be before you don't even bother with ray tracing. If you set it to 1, almost everything will look kind of shiny, even if it doesn't make sense. Or at the very least, ray tracing will be computed for everything in the scene, which, as you can imagine, will slow your processing down quite a bit. Things that are shiny enough to even be worried about, I think, will be 0.5 or less. It's like these countertops, this metallic objects, the window here. What else do we have? There's another window over here. You can see the light reflecting. So I think 0.5 is okay. Initially, I believe that this defaults to like 0.1. 1 bounce should be good enough for for this purpose at least. But you can set it as high as you think is reasonable. If you make too many bounces and your graphics card can't handle it, then you'll start to see noise like what we're seeing here. So I just keep it at 1. If you do have noise like that, you are supposed to increase samples per pixel, but then of course that's even more GPU overhead. So I'm just keeping these at 1 because I think it looks good enough. Shadows, I enabled hard shadows because if you don't, then your reflections will not be shadowy at all, and so you'll get really unrealistic reflections like this, where it doesn't realize that this reflection doesn't realize it's under a cabinet, so it's reflecting it as if it's not. So I would enable hard shadows. Include translucent objects I have disabled because I don't think I have I don't really have many or any cases of a translucent object being reflected onto another shiny object. So I didn't think it was necessary. And then I think I have ray trace translucency enabled because otherwise this glass window wouldn't work. It would be screen space reflection, which looks pretty. If this window were more opaque, it would look really, really bad. But even so, you can still see it kind of looks unrealistic. Like, for example, this is a reflection of the hallway back here, and it's not moving at all. It looks like an image almost. And it also wasn't reflecting that light up there. So, ray trace translucency, I would enable this. And again, I'm keeping this at all this stuff at 1. Refraction is hard to simulate, so it starts creating a lot of noise. If you do more samples, doesn't seem to be doing anything anyway, so. Oh well, keep it at 1. Shadows being enabled, so that's up to you. I kind of like the effect of not having shadows. Because if I enable shadows, you can't really see anything except this light here. Which may be realistic in a daytime scene, but I personally was just keeping it here. Which I think looks better. I wanted to see the scene behind me a little bit. Alright, so these are ray tracing features. It's up to you if you want to enable them. It totally depends on whether or not your data set will have a lot of shiny stuff. But anyway, moving on to how we actually create the sequence. First, you need a camera. In my case, I have this character who's holding a phone, because we were trying to simulate like a phone recording. So this is a very simple character that you don't have to worry about the iPhone, but it's basically just an actor that has a camera on it. You will need to, of course, tell Unreal to actually show the perspective from this character. So, oh god, let me turn desktop audio way low. Oh, it's okay. It should be low in the recording, but it's very loud for me. Alright, so it's rendering from his perspective. Now notice that this is an actor, not a pawn, so you wouldn't be able to auto-possess it through the game mode because you can only do that through pawns. So what I do is in the level blueprint in begin play, you get to level blueprint by going up here. Open level blueprint. You'll see begin play. In begin play, you need to say set view target with blend, which will tell this player controller to render from this camera perspective. So just do get player controller, get spell, get player controller, and then from there set view target. And then you give it something that has a camera. Or I guess if it's an actor that doesn't necessarily have a camera, it will just render from the forward perspective or something. I don't know, I didn't really try. And yeah, possess just won't work at all because it's not a pawn, so it won't let you do this. I also have some console commands here to enforce a certain frame rate and VSync. And this we'll worry about soon when I create the sequencer. Alright, so that is the camera. And now we can create the sequencer. The sequencer will be essentially the animation of the camera. So for my most recent test purpose, I had a sequencer like this, where the camera, oh, I have to enable game mode. G is game mode, by the way. If you don't enable game mode, then you won't see the trajectory. But anyway, it animated this camera going through the house, like this. So that was my test purpose, but yours might be different. Let's see. So I'm going to create one from scratch just for the sake of showing you how to do it. So you can do that by going up to sequencer and saying add level sequence. I'm going to just create one like test sequence. I'm starting this with an underscore so that it shows up at the top of the folder. It's just an organization thing. So once I come back here, or I guess it shows up at the bottom. Oh well. Anyway, when you open the sequence, it will close this. It'll open up the sequence there. Normally this will show up on a different window, like it'll show up like out here. But I like putting it down here, as with other animation programs like Blender, because I think this is more intuitive. So the first thing I'll have to do for the sequencer is tell it what to actually track. So I want it to track this camera called camera rig. So if you click this character first, it will show up here, actor sequencer, and then it shows up right here. Otherwise, you can search throughout the scene. So here I have camera rig. This is not keying anything yet because you can't key an abstract object like this. But you can key specific things like its transform. So I want to track its transform. And it gives me keys for location, rotation, and scale. Scale I don't care about because I don't want to scale the camera. That would, in my case, I wouldn't want to scale the camera because then the scale of the house wouldn't look right. Your character would look too big or too small. Also for rotation, if you don't expect to have this kind of motion, then I would remove roll from the keys. But if you want to have a realistic moving camera, like you're simulating somebody actually holding their phone, you probably do want to keep that. But for now, I'm just going to remove it. So at key 0, we're going to start by hitting plus here, and this will create the initial keyframe. Then there's an option somewhere here, key changed, which will it'll change the key whenever you move the character. So let's say that in 30 frames, this is at 30 FPS, so 1 second later, I want the character to be at the door. As you can see, it keyed the location because that's all I changed. Now, as you can imagine, having to move the character with this gizmo will become very tedious very quickly. So what I do, and what will also probably result in more natural animations, is pilot the camera. So I'm going to right click and pilot the camera rig. And now when I move the camera around, it is basically moving the camera rig itself. So I'm looking at the camera rig's perspective, looking from their perspective, and I'm moving them. So it keys the movement. So I'm going to make them move into the house. And there you go. This is the first second of this animation. If you want to play it, you can hit play here. As you can see, this is way too fast for somebody to realistically move. So I would say it takes 3 seconds to do this. That looks okay. You can continue to move it around. If you want more frames, you can just increase this part. Oh, I just realized that my mouse is not being captured, sorry. There we go. Okay, so if you want more frames, you can increase this and then move this bar. This red line right here is where the sequence ends. The green line is where the sequence starts. I still want it to start at 0, but I want to move red over here so that I have more frames to work with. Alright, so let's say that 3 seconds later, they move into the kitchen, like this. So this, I think that this part will end up being really, really fast. Yeah, it's pretty fast. One good thing about having a synthetic data set is that you can remove motion blur completely. So because of that, you actually don't necessarily need to worry about how fast they're moving because it won't cause motion blur like with a real camera. So you can set motion blur to 0. Otherwise, if you want to simulate a realistic camera, then set it to be 1. And when I do this, it'll end up being very blurry when they move this fast. So if I were to record this video, well, I guess I'm recording the video now, but if I were to export this video, each individual frame will look really, really blurry. But now it doesn't. So, anyway, let's say that I don't want them to turn until they actually get into the kitchen. So in that case, I can move them this way and have them look here. So I have this intermediate keyframe where they do that. And so you can make as many keys as you want. It just depends on how long you want your video to be. Let's say I get them to move into the den. By the way, though, I'm moving by holding right click and WASDing, which is a lot easier than any other kind of navigation technique in this case. So here we see my favorite issue. I guess you can't do much about this. But let's say that you don't want them to rotate left, you want them to rotate right. What you have to do is make yaw, like add 360 to yaw, so that the rotation is better, like that. If you create intermediate keyframes, it always has a chance of doing that. So let's say that right here, I want to have an animation where they're doing, I don't know, they get to the door and then they look back. Oh, this actually didn't look that bad. I'm not exactly sure how to simulate this happening. Well, I know how to simulate it happening. I don't know how to cause it, but let's say that I subtract 360. Sometimes you'll get this kind of error where they'll spin around like that. In that case, you just have to add 360 off or subtract. I don't know. I get this problem when I'm creating intermediate keyframes sometimes. Like I said, I'm not exactly sure how I cause it to happen, but it does happen. So anyway, this will be my animation for now. I'm not gonna waste too much time and create an animation that I'm not gonna use. So, oh, this is the view port, or this is the number of frames that are being viewed. To move end here. All right, so this is my sequence for now. One thing that can be an issue. One thing that can be an issue if you are using this synthetic data and you want to use it immediately without having to edit the video is when you make the recording. Okay, let me show you an example. Okay, so if you wanted to, you could export the video from Unreal and it will render it out with whatever settings you have here. The problem is that this is incredibly slow rendering it out. So if I capture the movie, sure, I'll save it, whatever. The build data always takes a long time for this house because there are so many meshes and I have very high quality or high resolution shadow maps. Uh-oh. One of my screens went out. Oh. It exported to the wrong screen. Well, no, it didn't export. It was showing me the capture, but on the wrong screen. Let me Let me try to move this movie render preview. There we go. So you can see that this is extremely slow. This is extremely slow. Or at the very least, it's much slower than I was expecting it to be when I made the animation. So rendering it through this way is not necessarily the best solution. Whenever I do this kind of thing, I render it through OBS instead. But then with OBS, you have the issue of how do I align the recording of the actual sequence with the actual animation. My trick is to bind F9, which is what I have set to be my hotkey for starting the video in OBS. I bind F9 to starting the recording. So you can ignore most of this code. It's not very pretty anyway, but I have these variables for timing. Actually, I guess that part is not important for you. Yeah, sorry, never mind. Well, I can still show you the general method. The reason that I had to do this in my case was because I was also exporting the tracking data. So I was exporting the ground truth, location and rotation of the camera so that we could test with an algorithm. If you want to do that, then you can do what I'm doing here, which is store time, which is time since I started the recording in OBS Studio. Then I have a Boolean that's just recording whether or not I should time it. And then I'm counting frame number. And so in tick, I am waiting until this Boolean is true to start adding all of the locations, or sorry, each line of data to this. Let me open up the data. Doing something wrong. Here we go. So I have data like this, and I was recording this. So the time since I started the recording, the frame number, the location in XYZ, and then the 3 rotations. And I was exporting this so that we can use it later on. To do that, I was waiting until this Boolean was true, and then when it's true, every frame I add these columns to this array of locations. So time and then these things. This function here will create a string that has a certain number of decimal places. You might be tempted to just round a float. Or not round, but what's this? Here we go, round decimals. You might be tempted to do something like this, but the float won't necessarily have 2 decimals even after doing this, because there's some rounding error when you convert to a string. So I use this function from the low entry extended library, I think. I thought it was from there. Oh no, this is from Rama's Victory plugin. So I'm using this to create values that have 2 decimal places, or in the time case for everything else too, just so that this file doesn't become extremely large with so many decimals. All right, moving on. This is turning into rambling, but when this Boolean here is controlled by F9, so when I hit F9, it resets all these things, and it also sets this Boolean to true. So F9 is being received by Unreal and starting the recording of the actual tracking data, and it's starting the OBS recording. So that's a trick. Since this camera rig is a generic actor, by default, auto receive input will be disabled. You need to make sure that this is player 0. Otherwise, the script won't actually read your F9 input. And then at the end, in endplay, I am exporting all of the rows that I have been recording into a file. To do this, I was also using the Victory plugin, and it has this file for saving an array of strings into a file, and each element of the array is its own line. And I also have some strategy for naming the file so that I don't accidentally overwrite data that could be important. So, yeah. That's pretty much it for the Unreal portion. I'm not going to record this because if I try to record this, then obviously I can't record this actual video. So I'm going to move on to the actual reconstruction part. So, let me open up my notes. Oh, one last thing. If you want to get rid of this annoying message right here, lighting needs to be rebuilt. These 17 objects that they're talking about are really, really tiny things in the scene. I don't want to do that. So I have this console command, this console command is built in disable all screen messages. So you can just do that and it'll remove this comment. Otherwise, if you think you'll forget, then you can just do execute console command and do disable all screen messages. And put it in begin play. And that'll have the same effect. Anything else in my notes? No. Alright, so I'm going to close this and show you a toy dataset in Metashape. Metashape is basically the state-of-the-art in consumer visual reconstruction. By visual reconstruction, I mean just using images. So let's say that through OBS Studio, I recorded that video using my F9 and that sequence. Oh, one last thing. Sorry, let me just open up the Unreal again. One last thing was I wanted to show you how to delay the recording for a bit so that you have some time to get situated. I'm just having Unreal open up again. Alright, mouse one. Okay, so in my script, or I think it was in my level blueprint, I had a delay here, so I delay for 300 frames and then I play the sequence. The sequence has to be in the level, by the way. At least I think it does. So I have a sequence that's just thrown in the level. This entire house sequence is the one that I was using. For test sequence, you can just click it here and then go into level blueprint, right click, and do create a reference to test sequence. And this will have the same effect. But this is basically just waiting for this amount of time before it starts playing. What you could do that would be even better probably is instead of creating this delay, you simply put this part into the F9 script. Where's camera rig? So just put this part into F9. The only annoying thing is that this variable is not going to be, you can't put this variable into camera rig because camera rig is a generic object that can be used in any level, but for the level sequence, or I mean for the level blueprints, every object in the scene is basically like a variable, but that's not the case here. So what you would need to do is create a variable that's a level sequence and then reference it. So create like a level sequence. Make it public, or as I don't know if it's called public. I call it exposed because it exposes this to the editor, but if you do this, then you can do this. Level sequence actor. Okay, level sequence actor. Here we go. So with F9, you would start the movie sequence and the tracking data recording and the OBS recording at the same time. And if you do this, then the last thing you need to do is just tell it which level sequence to use. So yeah, I'm not going to test this again because I'll stop this recording. But this should work. Alright, now we'll move on to Metashape. Let me delete those. Okay, so in Metashape, you would take in the video that eventually gets recorded through all of that. So I have OBS Studio recording as an FLV because FLVs I think have much less overhead than MP4s do. So I have this FLV of a recording. So this is the recording that started when I hit F9. So you can see that it starts at a pretty good position. Then you have to tell it where to output the frames that it's going to extract from the video. So I'm going to make a test sequence folder, and I'm going to make another subfolder called frames. And this video is, I believe, 30 FPS, and I have 10 minutes of it. I'm going to just stop it, just for the sake of us seeing what happens here. I'm going to only use a tiny part of the scene. So let's use the den. So we'll start here, and then we'll end here. Okay, so this is 2 minutes of recording, which is still a lot. That'll be 120 times 30 frames, which is a lot. 120 times 30. I'm not good at doing math in my head. So that'll be 3,600 frames. 3,600 frames takes a long time to process in Metashape. So I'm only going to use every 10th frame, resulting in only 360 images. So frame step I'll set to 10. And this is okay for now, just for our dummy example. This thing used 5,000 frames almost, and it took like 12 hours to process. So yeah, number of frames matters. While I'm waiting for this, I'm just looking at other scenes and my notes. This is a much better scene that we recorded. This was created with 1,200 cameras. If you hold Control, you can increase the FOV in Metashape, which makes it easier to see a cramped space like this. I only want it to be 90. Okay, good. 90 degree FOV. You could see that this recording came out pretty good, except for cabinets and this little wall in the bathroom. But this was generated from Unreal too. I show up in Unreal again, just to show you the source data for this. Metashape is... doesn't seem to be doing anything. But anyway, It does need to be able to find this. But you can do the assign actor if it loses the reference. So for master bath, oh well, that's just great. I figured it out now. So if I pilot this, this is a sequence that I used to create the source data for that bathroom. Okay, this does not seem to be doing anything for some reason. Could be that I have too much stuff open, so what I'm going to do instead is just add the photos manually. So I have Adobe Data Collector. Alright, so I had frames from the last time I exported this. I don't know when the den happens around here. You can see that there are definitely way too many frames. I'll select like this many. So this is 200 frames. None of them are aligned, so you can manually click these steps to have it go through these, but if I'm going to run this job overnight, I prefer batch process. So in batch process, you can say align photos. I'm going to use like the highest accuracy. Reference pre-selection, I'm going to do sequential because this is a video, so I know that the frames happen continuously in terms of position. Guided image matching, I'll keep as yes. Keep this as yes. I don't think adaptive camera model fitting needs to be yes. I think that's for if you are using different cameras for different frames or something like that. Anyway, next step, you can do optimize alignments. I personally do just because it doesn't take that long. These is yes. Then we have build dense cloud. High quality. Aggressive. Build mesh. You should use depth maps for this. If you try to use dense cloud, it will try to reconstruct geometrically, which doesn't really work that well for point clouds. Alright, I'm not actually going to process this during this video because that'll take too long, but I'm just showing you the settings that should be fine. Texture size, I don't know, like 8. Alright, so this would be like this would be the rough pipeline that you would want to go through to create the mesh. When you do align photos, you will first get this. You'll get the sparse cloud. You can click this camera button to show you the frames that were used. So it'll give you a sparse cloud, and it'll tell you that it'll align however many cameras. Some cameras, like cameras or frames that are looking at a featureless wall, can't be aligned. So those will get thrown away. Also, cameras that have a lot of motion blur will also get thrown away. And then when you do when you do optimize alignment, it'll just shift the cameras a little bit. But then when you build a dense cloud, it will create the dense cloud, which is this big, noisy cloud that shows a lot more detail, but of course it's noisy. You can look at the confidence of the points and see that a lot of the noise is red. And so before you build the mesh, you can kind of get an idea of what this would look like by removing the noisy points. So if I make the minimum 5, then it will only keep the relatively unnoisy points. So the reflection in the mirror caused this to it caused it to reflect these pictures, because I mean a computer vision algorithm is not going to know if the paintings belong here or if they're a reflection, because to the computer vision algorithm it doesn't make any difference. But this is definitely less noisy than it was before. And then when you build the mesh, you will first get model shaded, which looks like this. It's pretty ugly, but you can see that at least the surfaces look pretty good. And somehow their algorithm was able to crop that reflection that happened before. So that was nice. But this does look very ugly, but don't be alarmed. Once you texture, it'll look a lot better. So after you do the texturing, it'll end up looking like this. And so with this, you can export the OBJ and compare to the ground truth. The ground truth being this bathroom. Trying to not pilot this anymore. So you can use some kind of geometric comparison algorithm to see how well aligned this ended up being. So visually, this doesn't look bad except for the mirror, which we fixed with our own research, which plants it plants meshes where it uses audio and it bounces it off the environments to try to tell where the glass is. But a standard visual reconstruction algorithm will not be able to get the mirror, but the sync looks okay. Of course, if you move in closer and try to analyze that a little bit better, you'll see that it's not really round. There's a lot of bumpiness here because it's shiny. Cabinet looks okay, although it's still bumpy. But again, these are subjective comparisons. If you want to have something that can actually be published, you need an objective comparison. So I think that's it as far as this goes, as far as my tutorial goes. One thing that you want to make sure to fix is I've had a problem before where building texture would freeze indefinitely and also at random times, and I never figured out what specifically caused that problem, but updating Metashape to the newest version and clearing all of its cache fixed it for me. And also, so now that we have the sequencer, what you can do is export other channels besides just the visual lit version. So if you want depth or any of these other view modes, you can do that. And with the F9 trick, where the start of the sequence is aligned for everything, you can sort of just re-record as many times as you want. I'm trying to do depth. This is custom depth though. Scene depth, this is what I want. This is grayscale because depth is simply a scalar from the camera. So the farther it is, the more white it will be. But if you wanted to export this channel, you could. And then, use it in Metashape or whatever you want to do. Or some other reconstruction algorithm. Anyway, that's the end of this tutorial. It was long and kind of rambly, but hopefully this gives you an idea of how you can use a sequencer to create these reconstructions, which can make your life a lot easier, than trying to get ground truth for real scenes. So yeah, that's it. Good luck with anything you decide to do with my tutorial. Adios.